3 weeks ago, it wasn't there. Then it was. No warning, no build-up. One morning, a telescope array in Chile picked up something that shouldn't exist. A perfect sphere of distorted light, 2.1 million kilometers from Earth, roughly 5 times the distance to the Moon, hanging in space. Within 48 hours, every major space agency on the planet had confirmed it. Within a week, the best minds in physics had a name for it: a traversable wormhole, a tunnel in the fabric of space-time itself, one of the most theorized and least expected objects in the history of science. But the name wasn't what frightened people. It isn't just sitting there, it's station-keeping, locked to our orbital plane with impossible precision, moving with Earth as Earth moves around the Sun, maintaining exactly the same relative position day after day. No thrusters, no fuel signature, no mechanism anyone can identify. It simply decided where it wanted to be, and it stayed there. Nature doesn't do that. The math for wormholes has existed for nearly a century. In 1935, Einstein and Rosen described how space-time could fold back on itself, connecting 2 distant points through a shortcut that bends the geometry of the universe. Later, Kip Thorne worked out what it would take to keep one open: exotic matter with properties that push outward against gravity. Matter that holds the throat like scaffolding from the inside, preventing collapse. For decades, that exotic matter was the problem. Theoretical, possibly impossible in any usable quantity. This wormhole is open, stable, and aimed at us. From a distance, it looks nothing like the portals you've seen in films. No swirling vortex, no dramatic glow. It appears as a sphere of intensely lensed light. The stars behind it warped into rings where their light bends around the throat and arrives at your eyes from the wrong direction. Physics predicts that a wormhole like this produces 2 Einstein rings simultaneously, one near the outer edge, one at the throat itself. You can see both, nested inside each other, a circle within a circle of bent starlight. At the center, darkness, but not empty darkness. The center isn't black because nothing is there. It's black because the light coming through from the other side is being red-shifted into invisibility, stretched by the extreme curvature of the throat until it slides out of the visible spectrum entirely. Infrared. Gone. Something is on the other side of that darkness. You just can't see it yet. You have been staring at it for 3 days. Your ship left Earth 11 days ago. 6 of you, 1 vessel. The mission was decided in 72 hours. The fastest mobilization in the history of human spaceflight. There was no debate. Every government on the planet agreed on one thing: you don't leave a door like this unopened. You are now 4 hours from the threshold. Nobody has slept. 4 hours becomes 2. 2 becomes 30 minutes. You stop watching the clock. The wormhole now fills the entire forward viewport, not a point of light anymore, a structure, a presence. From this distance, you can see what the telescope images couldn't capture. It has depth. The sphere of lensed starlight isn't flat. It curves inward, pulling the background of the universe around its edges like fabric stretched over a hole. The 2 Einstein rings are sharp now. 2 perfect circles of bent light, one nested inside the other, rotating slowly around an absolute center of darkness. Your navigator calls out the distance: 800 kilometers, 600. The numbers mean nothing. Your brain stopped processing scale an hour ago. At 500 kilometers, the instruments begin to notice it, not dramatically, not a sudden alarm. The first sign is subtle, a slight disagreement between 2 clocks on board. Both were synchronized to atomic precision before departure. Now one reads 0.003 seconds ahead of the other. The wormhole's gravity is bending time, lightly, carefully, almost politely. But it's bending it. The physicist on your crew says nothing. She just writes it down. At 200 kilometers, you feel something. Not gravity, The wormhole's tidal forces at this range are negligible for a well-engineered structure this size, well within what a human body can tolerate. It's something else, a kind of stillness in your inner ear. The ship's orientation system is working perfectly, but some ancient part of your brain, the part that evolved to know which way is down, has stopped getting a clear answer. The wormhole doesn't pull you, it just makes space uncertain. 100 kilometers. The stars behind you look normal. The stars ahead of you don't. The closer you get, the more the background warps. The galaxy behind the wormhole stretched into arcs, smeared sideways, duplicated. You can see the same star cluster in 3 different positions simultaneously, its light taking 3 different paths around the throat to reach your eyes. The universe is showing you the same thing from angles that shouldn't exist. 50 kilometers. The mission commander gives the order to cut thrust. From here, you go in ballistic, no engines. The physics will carry you through. Firing the drive inside the throat could disrupt the geometry. Nobody knows exactly what that would do, and nobody wants to find out. The ship goes quiet. You have prepared for this for 11 days. Briefings, simulations, protocols. You know the entry parameters by memory. You know the throat diameter is large enough that tidal forces will stay within survivable limits. You know the transit will take seconds, maybe minutes, as measured by your own body. You know all of this. It doesn't help. The center of the wormhole is directly ahead. 100 meters across of absolute darkness. Not empty, not void, but light, shifted so far out of the visible spectrum that your eyes simply register nothing. Something is on the other side of that. Something you will see in approximately 40 seconds. You look at the crew. Nobody speaks. 30 seconds. You look back at the viewport. 20. 10. The edge of the lensing ring passes over the ship like a wave of bent light. There is no other word for it. One moment you are looking at stars. The next, those stars are everywhere. Above you, below you, wrapped around the hull in every direction. The light from both sides of the wormhole arriving simultaneously, bent into impossible geometry. Your forward viewport shows the galaxy you're leaving. Your side windows show the same galaxy, curved and repeated, looping around the throat like a mirror facing a mirror. And somewhere in between, a faint glow, infrared bleeding into visible light as the extreme curvature begins to relax, the first hint of what waits on the other side. It lasts approximately 4 seconds. For those 4 seconds, you are not in space. You are in the throat of a tunnel whose walls are made of bent space-time itself. The geometry here curves inward in every direction, folding back on itself. You are, in the most literal mathematical sense, in 2 places at once. A point that belongs simultaneously to the space you left and the space you are entering, connected by a region where the normal rules of distance simply do not apply. You don't feel it. That's the strangest part. A well-engineered traversable wormhole, one large enough and stable enough to allow human passage, produces tidal forces at its throat that are survivable. Tolerable, even. The difference in gravitational pull between your head and your feet is real but small. A few fractions of a G. Less than turbulence on an aircraft. Your body registers nothing unusual. Your mind is a different matter. In the throat, space-time acts as a curved optical surface, focusing light from both sides the way a lens focuses a beam. Physicists call this the caustic effect. But no diagram prepared you for what it actually looks like. It isn't a simple overlap, 2 images laid on top of each other. It's a transformation. The darkness ahead, that infrared void that showed you nothing for 11 days of approach, begins to expand. Not slowly, fast. It grows from a circle to a window to a wall, rushing outward to fill your entire field of vision in under 2 seconds. At the same moment, the galaxy behind you does the opposite. Everything you know, the Sun, Earth, the Milky Way's spiral arms, compresses into a single brilliant point of light directly behind the ship. A white dot, getting smaller, still there, they're not there. And the window ahead is no longer a window. It's everything. The first thing you notice is the stars. There are too many of them. Back home, back on the other side of that throat, interstellar space is mostly empty. Dark. You can see thousands of stars on a clear night, but between them is nothing. Vast, cold nothing. Here, the nothing is smaller. The star density around you is far higher than anything in the Milky Way outside its core. In every direction, stars, close stars, overlapping stars. And because of this, because there are simply too many of them to leave gaps between, the sky is not black. There are no shadows here, not truly. Every shadow that forms on one side of the ship is immediately filled by light arriving from another direction. The integrated glow of billions of suns whose light overlaps before it reaches you. Even the darkest corner of the cabin has a faint, sourceless luminance, a blue-grey haze that comes from everywhere and nowhere. Your eyes have never processed a sky without true darkness before. It takes several minutes to understand why something feels wrong. Then you realize you cannot find the dark. You are inside a different galaxy, not near it, inside it, the way a fish is inside water. This galaxy, the one you're now embedded in, spans roughly 220,000 light-years from edge to edge. You are a single point within that structure. The nearest edge is tens of thousands of light-years away in any direction. The structure surrounds you completely, without end, the way the Milky Way surrounds Earth, except you have never seen the Milky Way like this, from inside a region this dense, this bright, this crowded with stellar machinery. Nobody speaks for 43 seconds. The mission log records this as a communication gap. You remember it as the longest silence of your life. Then the pilot says, "Run the cameras." This is the right call, because here is something the astronomers back home understood but couldn't adequately warn you about. To your naked eye through the viewport, the galaxy around you is not the explosion of color you have seen in Hubble photographs your entire life. Those images are long exposures captured over hours, false color mappings of wavelengths your eyes can't detect, enhanced and processed to show what the universe contains rather than what human vision can perceive. What your naked eye sees is subtler. A sky crowded with stars, some close enough to cast overlapping shadows that are never quite dark. A broad sweep of silver haze in one direction, the galactic plane, dense with dust and unresolved light, stretching from viewport edge to viewport edge. Shapes in the dimness that your brain wants to call clouds, but which are stellar nurseries, thousands of light-years across, visible only because they block the stars behind them. But the cameras see everything your eyes cannot. The first image comes through 12 seconds after the pilot gives the order. It fills the main display screen. The crew goes quiet again, a different kind of quiet this time, not shock, something slower. Hydrogen alpha red bleeding across a region of space to your starboard side. An emission nebula in the full flush of star formation, its ionized gas glowing in frequencies your eyes are blind to, now mapped to visible color by the ship's imaging system. To the left of it, a curtain of cool dust scattering starlight into deep blue. Between them, embedded in both, clusters of young stars burning white and violent, only a few million years old. You are looking at a place where stars are being born right now. The navigator begins calling out readings. A gas giant 11 light minutes away, detectable by its gravitational signature. A rocky body with a surface temperature in the range where liquid water could exist. A triple star system close enough that all three components are separately visible without magnification. One amber, one blue-white, one deep orange-red. Their combined light fills the cabin with a color that has no name because no human eye has ever seen this particular mixture before. You scan for signals, radio, microwave, anything structured. Anything that breaks the pattern of natural noise. Nothing, not yet. The galaxy around you is alive with chemistry and physics and the slow machinery of stellar evolution. It is not alive with anyone talking, At least, not on any frequency you know how to receive. You tell yourself that's a small distinction. You're not sure you believe it. You don't sleep. Nobody does. The cameras run continuously. The instruments fill drive after drive with data. Someone is always at the viewport, watching the triple star system slowly arc across the sky. 3 suns moving at 3 different speeds, their light mixing and separating as they drift. At one point, near what your ship clock calls 3 a.m., all 3 align. For 11 minutes, the cabin fills with a light the color of warm copper. By day 3, you have established something important. The rocky body the navigator flagged on arrival, the one with the right temperature range, has an atmosphere. Thin, mostly nitrogen and carbon dioxide, not breathable but structured, not a random collision of gases. A planet that has held onto an atmosphere means a planet with sufficient mass and magnetic field. A planet that is, in the language of planetary science, trying. You name it, informally, not officially. That decision is above your pay grade, but you name it anyway, the way humans have always named things they find in the dark. Day 5 brings the anomaly. It starts as a pattern in the stellar distribution data, a statistical irregularity the ship's AI flags with low confidence. The stars in a region approximately 4,000 light-years to your galactic north are not randomly distributed. Random distributions have a specific mathematical signature. This one deviates slightly. Just enough that the AI assigns it a probability of 94% that the deviation is not natural. 94% is not proof. It is not even close to proof. But 94% is also not nothing. You spend 2 days running the numbers yourself. Different methods, different assumptions, same result. The deviation holds. The stars in that region are spaced in a pattern that is statistically improbable for a natural process. Not impossible, improbable. There is a difference, and you are very careful to remember it. The crew has one conversation about what this might mean. It lasts 4 hours. It ends without a conclusion. Nobody writes it in the official log. You all agree, without saying so directly, that this particular data point needs to be examined by people with better tools, more time, and less at stake emotionally. You are 6 humans who have been awake for most of 13 days, 2.5 million light-years from home, staring at a pattern in the stars that might be nothing. Might be. The rocky planet rotates into a geometry where your instruments can scan its night side. The results take 3 hours to process. When they come back, the physicist stares at them for a long time without speaking. Then she says one sentence. The heat distribution on the night side is not uniform. It should be. A planet with no internal heat source and no sun on its night side should cool evenly. This one has a region, small, localized, approximately 200 kilometers across. That is measurably warmer than the surrounding surface, not dramatically, a few degrees, but consistently across multiple scans in the same location. Geology can do this. Volcanic activity, tidal heating, subsurface chemistry. The planet is not confirmed to have any of these, but it could. It is physically possible. The physicist writes this in her notes. She writes it carefully and at length, as if she is building a wall between herself and a conclusion she is not yet willing to approach. You photograph the warm region at every resolution the ship's instruments allow. You collect 847 images. You will spend years analyzing them back home. Day 13 arrives the way the end of things always does, faster than expected. The wormhole is still there. You can see it from the other side now. The same sphere of lensed starlight, the same nested Einstein rings, but the galaxy visible through its center is the Milky Way. Your galaxy, home, compressed into a circle of bent light. You have been gone for 13 days. On Earth, 13 days have also passed. The wormhole preserves temporal continuity perfectly, both clocks running in exact synchrony. No time debt, no years lost. The people you left behind aged the same 13 days you did. That should feel like a relief. Mostly it does. The commander gives the order to begin return preparations. You back up every byte of data to 3 separate redundant systems. You run the approach checklist. You do everything methodically, professionally, the way you were trained. And then, before you take your seat for the return transit, you stop at the viewport one last time. The warm patch on the planet's surface is still glowing faintly on the instruments. The stellar anomaly is still there, 4,000 light-years away, its improbable geometry unchanged. The 3 suns are in their slow rotation, amber and blue-white and deep orange-red. You look at all of it. You try to memorize it. You know you won't. The second transit is different from the first, not physically. The physics are identical. The same 4 seconds, the same caustic bloom of light expanding to fill the viewport, the same compression of the galaxy behind you into a single white point. Your instruments record no difference between entry and exit, no variation in tidal force, no anomaly in the throat geometry. The wormhole does not care that this is your second time. It performs the same. You are different. The first time you went through not knowing what was on the other side. That unknowing was its own kind of weight, a pressure that had been building for 11 days of approach, for months of training, for the entire history of human spaceflight leading to this moment. The first transit emptied that weight out of you in 4 seconds flat. The second time, you know exactly what you're leaving behind. That is heavier. Then the Milky Way is everywhere. Your galaxy, your home, spread across the viewport in a configuration you have known your entire life. The familiar star fields, the pale band of the galactic plane, the specific and unremarkable darkness of local interstellar space, everything exactly where you left it. The Sun is a bright point 2.1 million kilometers ahead, Earth a smaller point beyond it, neither of them aware that you were ever gone. Your ship clock reads 13 days, 4 hours and 17 minutes since departure. Mission Control's first words, when the signal locks in, are, "Welcome back. Confirm crew status." 6 voices answer, all present, all intact. The debrief begins before you land. What follows, over the next weeks, months, years, is the largest scientific mobilization in human history. The data you brought back fills entire server farms. Teams of astronomers work around the clock on the stellar distribution anomaly, running models, checking assumptions, arguing in journals and conference rooms and late-night video calls. The rocky planet's heat signature is analyzed by geologists and astrobiologists and atmospheric chemists who disagree loudly and in public about what it means. The wormhole is still there, stable, unchanging. A second mission is approved within 8 weeks, then a third. A permanent research station is established at the mouth, humanity's first structure outside the Milky Way, 2.537 million light-years from Earth, reachable in 4 seconds. The impossible has become infrastructure, and through all of it, through the press conferences and the peer reviews and the political arguments about who owns what on the other side, one question keeps surfacing. Not loudly, not in the official reports, but in the margins, in the conversations that happen after the cameras turn off. The wormhole appeared 3 weeks before you launched. It aimed itself at Earth with mechanical precision. It held its position without any mechanism anyone can detect. It was, from the first moment of its existence, exactly large enough for a human spacecraft to pass through safely. Not larger, not smaller, exactly. As if someone had checked. The stellar anomaly sits in the data, unresolved. The warm patch on the night side of the rocky planet sits in 847 photographs, unresolved. The wormhole sits 2.1 million kilometers from Earth, open, patient, unresolved. You think about doors. A door is a passive object. It doesn't do anything on its own. But a door implies a maker, and a maker implies intent. And intent implies that whoever built the door had a reason for putting it exactly where they put it, aimed at exactly what they aimed it at, sized for exactly what they expected to walk through. You have been through the door. Something knows that now.